Hi everyone.
Hello, everyone. It's a slow morning.
I feel like at this. We have got a lot better at getting set up. To be
Oh
fair,
yeah,
we,
that's
we
true.
haven't. When was the last time we had to reboot? Was that a few days ago?
I think so. No, actually, I had to reboot yesterday, at least once, but quickly.
Yeah. You want to tweet that we're live now?
Yeah, I just retweeted it. Oh, yes. No, I shall proper tweet.
So today
Yes.
we are day 7. We're doing. We got all of them done so far. Um,
Yeah.
I'm wondering what is the picture gonna be? It looks like we're under the sea. Um, Can't really tell much more than that at this stage. But day 7. Alright, while you tweet, I will read this. Okay, the treachery of whales. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Love there's like a Wikipedia link to whale. Suddenly, a swarm of crabs, each in its own tiny submarine. It's too deep for them otherwise. That's just adorable. Zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. Here's one major catch. Crab submarines can only move horizontally, of course. Quickly make a list of the horizontal positions of each crab, which is our puzzle input. They have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. Take list of positions. This means that there's a crab with horizontal position 16, then 1, 2, 0, so on. Each change of one step in the horizontal position costs 1 fuel. You can choose any horizontal position to align them on, but the one that costs the least fuel is 2. Okay, and then it walks through that. This is the cheapest possible outcome. So to determine the horizontal position that the crabs can align to using the least fuel possible. How much fuel must they spend? Hey Walter, how's it going? Alright, so I think that you can take the median here, but I'm not certain.
Yeah, we were talking about it like pre-stream, like how do we do this? This kind of looks like median, kind of quacks like median, but is it median?
Also,
Um,
surely you have an advantage here using Rust just for the domain of crabs.
yes, exactly. I feel like we can hit the crab accelerating pass in the compiler. Definitely.
So like my feeling here is that we can split them, do a partial sort to get the median element, and then just sum up all the distances from the median element to all the other ones. Done.
Yes.
And
Yes.
then if it turns out that we're wrong and you can't actually use the median, then we can just calculate all of the distances from each position from min to max and then
Oh
find the
no.
min element.
Oh no.
But we'll try median first.
Yeah. Let's do that. Let's do that. Sounds good.
Alright,
All
we're
right.
gonna get started.
See
See you
you
on
in a
the other side.
bit.
Alright, Yosh is gone.
Uh, All right.
Okay.
Hey. Good morning. Hey Walter. Hey Pepple. Hey Nero. Hey
Yosh, you're not
Kamitsa.
muted on my
Oh,
stream.
I'm so sorry.
Okay, let's get going. So we're gonna include um our split helper. We're gonna include TL get lines, and we're gonna do the same as we did last time. Oh, we don't even need to split lines. Get lines even. We can just do split the input into crabs, and then to get the Exposidon, I feel like you do maybe need to brute force this, but we'll try it with the median. If it doesn't work, then we'll do it the I don't know, the right way, the brute force way. So then we can get the median by doing. See, we could do a full sort and then find the middle element, but we could use, there's an algorithm called nth element, which just does a partial sort to get the nth element into the correct sorted position. So that's an algorithm. So we can do std ranges nth element, crabs, std ranges begin. So we need to give it the midpoint, which is std ranges begin of crabs, plus std ranges size of crabs divided by 2. Okay. That should give us the median, and then with the median we do std c out. Oops. Am I missing a parenthesis here? No. Hey, thanks to follow Calisbara. Oh, we've already got IOStream. Okay, so now we want to do a accumulate. We can do crabs. Wait, let's get all of the sums, all of the distances first. So distances equals crabs piped to std views. Whoops. Transform. Oh wait, this is transform reduce, right? There's an algorithm for this already. Std ranges transform reduce. Pretty sure. Oops. Oh, is it just in... There's no range version of it yet. It's just the... Okay, that's fine. We can just do std transform reduce from crabs dot begin, crabs dot end, and we take the initial value, which is going to be 0. Our reduction is std plus. Our transform is for each crab return the absolute value of crab minus median. This is our answer, right? I think. Let's give it a shot. Hey, thanks to follow Hedron K. Okay, let's use this. I don't know if our maths is actually right on this being median, but we'll give it a shot. What's failed here? I missed a semicolon. What's going on here? Minus no global operator found, which takes vector iterator on line 11. is a median is an iterator, so I need to dereference it. Nth element returns an iterator. Okay, this gives us an answer. Oh, debug assertion failed. What happened here? Median was not correct. Okay. What is crabs? Crabs is this. Okay. What went wrong with nth element? What does nth element return? Nth element returns void because we... Okay, fair enough. We just have to save this iterator. Median point is this. It doesn't... I feel like std range's nth element should return you the iterator just for... Oh, whoops. It's a nice usability... It would be a usability thing, but I guess it doesn't really matter. 37, is that correct? 37, that is correct. Okay, let's give this a shot. Yeah, like, Seth, I don't know if median is actually correct, or if... I mean, it seems like it could be correct, but my doing maths on stream, as you know, is not one of my... Okay, it worked. Hey Josh, we did part 1.
We're almost done here. I need like 3 more minutes to walk over them and compare them.
Okay.
But it seems like the median thing worked out then.
Yes, the median thing did work out.
Nice. Yes. Perfect. Okay. I'll be right there.
All right. Do you want to share your screen and I can tune in while you finish up part 1?
Yes. So I don't have a second monitor today, so everything's like, oh, let me find like... Yes. Share screen 1. Okay, where's that share button? Oh, there it is. Okay. So we just verified that median indeed gives us the select nth unstable indeed gives us the median. So now we want to like loop through nums dot map num, I believe, or let's name this n, and then we say we want to find the distance, right?
Yeah.
Which maybe there should be an I-16 or an I-32, so we can do something to the effect of like n. Oh, let's name this median. Median minus n dot apps.
Yep.
No, that doesn't work. Nope. You need to wrap this in brackets. Sum.
Yep, it's pretty much what we did. We just... C++ has a transform reduce algorithm, which is the same as doing your map and then sum.
Oh, transform reduce.
Mm-hmm.
Interesting. Huh.
C++ calls map transform for some reason.
Oh, right. And then, yeah, so we have like a very convenient little sum, which is like reduce essentially, but
Yeah,
just for
we don't have a
numbers.
range based sum algorithm yet. Our sum is called accumulate. We don't have a
Ah, cool.
ranges based one yet because accumulate is one of those. So most the things which we call algorithms in C++ are in the algorithm header. Then there's a few which are in a header called numeric, and accumulate is one of them. And the algorithms in numeric did not get range based ones, mostly because of time. Like um, the standard proposal for adding ranges to the standard was like hundreds of pages. Um,
Oh
so they
no.
just didn't have the time or bandwidth to do the numeric algorithms as well as all of the ones in the algorithm header itself.
Yeah, that makes sense. Do you think that will like happen eventually?
Yeah. It's definitely planned. I don't know if it's planned for. I imagine it's planned for 23, but I might be. I don't keep up as much as I used to anymore.
Yeah, makes sense. Uh-oh. Wrong
That looks like
answer.
a very big answer.
Yeah, I was like,
It's a
that's
lot higher than mine.
all
Maybe
right.
did we
So
hit something for like for my input median happens to work and for yours it doesn't because that could happen.
wait, what were they saying? Your answer's too high. Yeah, that makes sense.
I mean, but
Uh,
your answer looks very high. Like what was my answer? My answer was um yeah, my answer was 355,000. So your answer is like orders of magnitude higher than mine. So I think you most likely got some.
oh no,
Wrong.
people correctly pointed out that I was copy and pasting the output from day 6, not day 7. Day 7 failed
Ah, yes, that would explain
because
it. If you're trying to use the completely wrong answer, that would help.
the
Yeah.
answer is we hit the same bug I believe we
Oh
hit
yeah, the
yesterday
new
where I
line
wasn't
at the
like
end of
trimming the
your
input.
yeah.
Yes. Day 7. All right, that looks a
Yeah,
lot
that looks
better.
a lot more reasonable.
All right, let's try again. Hey, that was right.
Yay!
Cool.
All right, can you kill your screen share and then we can have a look at part two.
I shall certainly try on this tiny screen. Oh, here. Yes.
Okay.
All right. Part 2. The crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. Rustacean memes. Yes. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. Move from 16 to 566 fuel, 1 to 510, etc. This costs 168 fuel. This is the new cheapest possible outcome. The old alignment position 2 now costs 206 fuel instead. Determine the horizontal position that the crabs can align to using the least fuel possible so they can make you an escape route.
Okay.
How much fuel do they spend?
Well, we're gonna have to do maths on stream now, aren't we? Damn.
Oh no.
Well, I mean, it seems like we do. Right. So the brute force way of doing this, maybe there's a smart way, but the median will definitely not work anymore. Uh,
Yep.
the brute force way that I see is take the minimum and maximum of your input, loop for um, every integer between 0 and between the min and max, because like Seth's just said in my chat that 5 isn't actually in the input, so we have to loop from all the numbers from min to max. We can't just loop over our inputs, so we loop from the minimum value to the maximum value, like all integers in between. For each integer between those two, we calculate the distance from all the other inputs to that place, taking into account this cost function, and then take the minimum value of those. I think that is a valid brute force algorithm for this. And the cost function is a partial sum. Is that right?
I don't know what a partial sum is.
Alright, let's give it a shot.
Yeah. I wanted to say, like, do you want to spend like 1 minute like thinking if there's maybe a smarter solution than brute forcing?
Okay, let's think. I
mean, I think we'll like for sure go with the brute force one, because my maths are like terrible, but I kind of want to think about like is there something better?
MetaRoboter's saying, does a function we're optimizing have more than one local minimum? Yeah, because there's probably some statistics like searching, because we're trying to minimize a cost function, right? So there's statistical algorithms for this that I don't know off the top of my head.
All right. Yeah, I think you're right. Yeah, I think it will require statistics, and for us to like understand like, hey, it's that problem, but neither of us like can say that like right now. So yeah, I think I agree. Let's do the brute force. That was a 1 minute. Let's think about it. Oh God, let's not. All right. Good luck. Boom, 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 boom. Okay. I did not read chat. What do people say?
Josh, you forgot to mute yourself again.
Oh. 1 sec.
Okay. So part 2 is gonna be take our crabs. Let's do a distance function. Or let's call this cost from our crab position to some destination. The cost is what's the nicest way to do this? Is this partial sum? Partial sum of iota from 0 to destination to ABS destination minus crab. Maybe it is turn state ranges partial sum. Oh, you know what? I'll just result equals 0. Auto I equals 0. I is less than std ABS destination minus crab plus I res plus equals I. That do. So we do our min and max is std ranges min max element, which is a way of getting both the minimum and maximum at the same time. Then we do std ranges iota, sorry, std views iota from min to max plus 1, pipe to so for each of these, we're going to do std views transform position. I'm going to capture crabs, and this is going to be the sum of the distances. So this is going to be our transform reduce from here. Crab minus position. So then that's going to be a range of all of our costed positions. That is a name. And then we just want to see out std ranges min element of costed positions. Yeah, let's just run it. Syntax error. Yes, missed semicolon there. A least squares combined with a new cost function. Probably, like I said, my ability to do math on stream is non-existent. Oh, business and iterator. Position. No global operator, which takes T1. What's going on here? Min-max element returns an iterator. Ah, okay. Thank you. Number. Ah. Okay. Is advent of code down? Unfortunate. Well, while we're waiting, let's try with this input and make sure that we got the right answer for it. 37. No, that's not right. Oh, I forgot to use my cost function. cost from C to position. $168, that's not right. Went 206. What's going wrong? Well, we dump this out to vector to see what our cost positions are. TL2 stood vector. Oh, 168 is right. Oh, yes. Sorry, I was just looking at 206 there. 168 is right. Okay. Silly me. Alright, let's see if this is back online yet. My actual answer. What's happening here? Or did I make a change which broke this? Why is this infinite looping? Oh, it's back. Nice. I got my answer just a few minutes ago. What's going on? Alright, let's just do that cost thing which Seth is saying. Thank you. Is that where n equals stood ABS crab minus destination return and multiplied by n plus 1 divided by 2. I'm building in debug mode, to be fair. Yay! Alright, Josh, we're done. Milkshake, what are you up to? Got a cat who's just destroying the universe here. Hey, do you want to come say hi? Do you want to come say hi to the stream? Look, I got a toy for you. Yeah, come over here.
Hey.
No. Milkshake doesn't want to come say hi.
Oh. We are still working on it.
Yeah, the puzzle inputs are based on your username, I believe.
Oh, actually. That's kind of fun.
You want to share your screen?
Should I share my screen again?
Yeah.
Yes. Oh my god. I'm trying to find all the right buttons. Okay, that works. Share. Screen shared. Can you see?
Mm-hmm.
Oh, should I have this? No. So we just got a vec of all of our positions. So we're doing the brute force method.
Mm-hmm.
We got the min and max correctly. We have our positions now. And now we want to like loop through and find the minimum position, the minimum distance, minimum total distance, I believe.
But you're doing brute force part 1. You're not doing the cost function from part 2.
Oh, I'm not. Yeah, you are right. Hey. So we need to multiply this, right? Was it 5 fuel per step?
No. The number of fuel increases by 1 each step.
Ah, I see. Wait, what's the math on that? Because
It's
like if you know the number of steps you're taking,
it's where n equals what you have right now. It's n times n plus 1 divided by 2.
n times someone posted 1 plus distance times distance divided by 2. Okay, hold on. So that's our distance, right?
Mm-hmm.
And then they said 1 plus this times this divided by 2.
Yep.
Does that look right?
Mm-hmm.
Okay. Yes. Okay, great. And then we can like loop through and find our minimum. Better some brackets there. Oh yeah. Like that, right? I feel like we can like loop through, do a sum. No, we can't do a sum. Can we do a sum? I feel like we can do a sum.
You want to, so you've looped through every. Yeah. So instead of doing a collect after your map of the, after your map of the cost function, you just want to do a sum there, and then take the minimum of that range.
Wait, which collect? I have two collects. 34 and 32.
The inner collect. The inner collect should be
Yes.
a sum.
Oh, I think I'm iterating over it like slightly different than you. I don't think the sum here would work. I would need to change this, I think. Because I'm mapping the positions.
Okay.
So-
right.
Yeah. I flipped it.
Yeah.
Can I do this differently?
Put the min max on the
Outer loop.
on the outer loop. Yeah.
Yes, you are right. Okay, let's change that. I'll just copy and paste this, modify it, and then delete the first one. So, into iter.
I don't think you're even going to need the nums. I think you can just get the answer from all this. Yeah, you do the.
Oh, sick.
Min max integer and then map. There'll be pause. Yep, and then inside that, you're gonna map each crab.
I'm gonna what now?
Yeah. So you're currently iterating on each possible position. So you want to
Yes.
then inside that iterate over each crab position, run the cost function, sum them.
Yeah.
Milkshake.
Yes. Nums dot iter dot map num
I do a sum instead of a collect.
Yeah, you're right. Something's off with my syntax. Because it is not auto-completing. Oh, there it is. I didn't close this out. There we go. All right, expected. Okay, that's because returns option. Is that right? No. What does sum return? It does return s sum.
I think isn't it just you're trying to assign this all to a vec of vecs?
Oh, hey, that'll do it. Let nums. Count, subtract, and vec I32 from I32. Oh, that's because we changed nums there. Let's try this again. Type annotation needed for option. Intuitor. What's going on? Let's look at the big diagnostics. Associate type map. Oh, type inference is like getting super confused. Intuitor I32 map, and min gives us that, and then we need to give this I32, something like that.
Seems reasonable.
Is min the right one? No, hold on. Min is actually wrong.
No, min's what you want there.
Okay.
Because you've looped for min to the max. You've collected. You've summed up all of the costs for each crab, and then you just want to get the minimum one. So
Yeah. Okay, but that's not the end of it. But we can still like run it and see whether it matches.
that is the end of it,
So-
isn't it?
So min is 147. Wait.
So
Is
someone in my chat was saying your parentheses around the dist divided by 2 is actually wrong. That'll break it.
Oh, wait. Does it need to be like that?
Yeah.
Run test. 168.
Yeah,
oh,
that's correct.
What? Okay, hold on. Did we just solve it and I didn't understand how, but we just did? U size. Okay. As U size. There we go. Let's go again. Boom. All right. Wait, hold on. I want to understand this. How did we do this?
Right. So
Because
you find the min and the max of the crabs, right? That tells you the range of possible answers. Then for each possible answer,